Welcome to another Chinchilla Squeaks, where I speak with tech luminaries, tech entrepreneurs, tech people generally. And tonight, for me anyway, I am joined by Venkat from Rockset. How are you doing, Venkat?
I'm doing very well. Thanks for hosting me. Pleasure to be here.
It's a nice background you have there.
Compliments to our design team.
I keep wanting to do more with this, but I haven't really got around to it yet. And I have way too much shadow. I really need something like you have with this cool kind of graphics and stuff like that.
Sorry for stealing your thunder.
Totally fine. I'm always quite happy when guests are prepared, so it's completely fine. So Rockset, I think I have my own ideas kind of where it fits into the whole sort of ecosystem of things, but why don't you describe what Rockset is and the problem you're trying to solve for people?
Perfect. What is Rockset? Rockset is a real-time database in the cloud. Databases have largely been usually just falling in two categories. OLTP, or transaction processing, on one end, and data lakes and warehouses on the other, right? And OLTP systems gives you speed, like everything is fast to build applications and what have you, but it's very hard to scale. If your computation complexity gets analytical and very complex, it's hard. If your data volumes grow, it's hard. Your write volumes grow, it's hard. On the other hand, lakes and warehouses are amazing at scaling. They can, manage petabytes of data, but it is slow. You really can't expect to build an application where the queries never stop coming and you want interactive speed. The data never stops coming and you want real-time, access and, fresh data sets. So really, I think what Rockset is the only system that gives you a combination of speed and scale with the simplicity of the cloud, right? And so it's a fully managed, offering in the cloud, built for the cloud, and it's a real-time database where you can, send massive streams, you can index, you can send massive amounts of data to Rockset and instantly build very, very fast interactive applications and dashboards simply using SQL. Sorry, I can't hear you.
Hardware.
Yes.
Is it an observability database for metrics, or is it a database for application data, or what's the data we're storing?
Perfect. It is business data. It is application data. So I'll give you a good example, right? One of our customers is has a huge platform for supply chain management for heavy construction. Mm-hmm. So anytime a concrete truck is driving around, all of those things are tracked in real time, in say DynamoDB or some transaction processing system. And in this case, it happens to be Amazon DynamoDB. Mm-hmm. Hundreds of millions of records getting updated. And how would you build real-time search on that, real-time analytics on that, where there's lots of records coming in and you want to be able to join and provide real-time reporting, real-time search, real-time analytics. And they want to build all of that for their customers as part of their platform. And here the data is changing all the time, and it's getting updated based on where the truck happens to be. Every time it crosses a turnstile. So this is all business data. This is all logistics, supply chain. A lot of the time, it's business data for doing sales operations, marketing operations, customer support operations, security operations, risk operations in finance industry. Anything where real time matters, right? Like, don't tell me that something bad happened, hours ago or days ago. Yeah. Tell me what's happening right now.
And is it, because you mentioned on the website real-time indexing database, is it an index of data elsewhere, or is it you replace your databases with Rockset?
Extremely good question. So it is a lot more of the former. So why is indexing important? A lot of people say, why aren't you just a real-time database? Like, why is indexing? So the real thing with real-time is two things happen the minute you start building, looking at real-time analytics. So why, a lot of the people will say, well, I don't really need real time. I only look at this thing once a week. So what if it's 2 hours behind? As soon as real time analytics comes into picture, people don't want humans to look at that. People want automation. People want alerting. People want to be machines and programs and applications are going to be looking at that data, and they're going to be looking 24/7 because they're never going to get tired. They don't need overtime, and they will alert a human on the other end when it actually demands their attention, and so it very quickly gets into application. So indexing is very important there, because if your data is coming and data is fresh, but every, let's say, query takes 20 minutes to come back, 40 minutes to come back, which is what you expect from a warehouse, or hours to come back, well, you don't really need real time, right? Like because my queries are slow. So indexing is one of the core techniques that Rockset has built completely in. So you have to do extra steps to not index data in Rockset. Like by default, when data comes in real time, within 1 to 2 seconds, the entire data set across all fields get fully indexed. The data could be structured or semi-structured, and it automatically gets indexed into fully typed, fully indexed SQL tables, so that you can get very fast SQL out of the box, SQL queries out of the box. So indexing is a very key component, because we end up serving applications. And now you said, are we indexing data elsewhere? For transaction systems, yeah. So, if your system of record is DynamoDB, MongoDB, MySQL, Postgres.
I can see you have a few here, yeah. Dynamo, Mongo, exactly. MySQL, Postgres. Exactly. And then you have some cloud object storage, S3 and Correct. GCS. And then Kafka, which is also kind of interesting.
Yes. So we have all three types. We have transaction database sources. We have real-time streams, Kafka, Kinesis. You can just plug that into. Or you could also have, point us to whatever data is sitting in your data lake, S3, GCS, and we will index all of the data in real time and give you fast SQL queries on the other side for application development.
Okay. And I can see already lurking on your website, you have the kind of comparisons to some of the obvious competitors here, which are relatively mature. But yeah, so how does Rockset compare to something like Elasticsearch and all the projects that came before it, like Lucene and Solar and et cetera, et cetera?
So there's like a bunch of open source, like born in data center kind of technologies that are there. Elasticsearch comes to mind. Apache Druid comes to mind. I think there are really, really good systems on premises. They're just not built for the cloud. They don't have compute storage separation. And also, they don't have full-featured SQL. Mm-hmm. So when you don't have full-featured SQL, the operational complexity of these systems go through the roof. Because you can't do read-time joins, you have to do write-time joins. And the minute you do write-time joins, you have to denormalize your data, and the data gets inconsistent, and like your real-time analytics doesn't agree with your batch analytics. And it's just a total mess, right? And so a lot of people look at those systems and say, oh my God, it's operationally complex. Mm-hmm. What people aren't really saying is like, installing it and configuring it is not really the problem. When I build solutions on top of systems that don't have joins, and that aren't built for the cloud, not just the server operations and all of that gets complex, the data administration aspects of that also gets tremendously complex. So in short, none of those systems are really built for the cloud. They're not born in the cloud. And they don't have full feature SQL, and vice versa is also true. If you are really looking to build a great real-time analytics solution in your data center, you have, you're a big bank and you have a huge data center. Well, Rockset can't help you. You have to be in the cloud for you to be able to use Rockset, which is where we think we have a much better offering because we are born in the cloud and we only run in the cloud.
So I think this might lead nicely into my next question, which is, where did you come from? Like, why build it? I'm getting the impression from what you said and from browsing around the website that it's not open source, it's not self-hosted, it's all cloud-hosted. So yeah, where were you when you kind of had this problem that you wanted to resolve and decided to create Rockset?
Awesome. A little bit about me and the team. So I was managing all online data infrastructure at Facebook.
Okay.
And I was there between 2007 and 2015. And these were like the hyper growth years. And by the time I left Facebook, the online data infrastructure was serving about 5 billion queries a second. And so massive scale. And we saw the transition amongst many other things. We saw the transition of, batch-based applications and systems moving to real time. And that was one of the biggest trends that I would say Facebook did that. And I tell this story to a lot of people, and most people are surprised to hear it, which is the first version of Facebook newsfeed was a batch-based system. It would basically run an ETL on everybody's activity, and it'll build a newsfeed every night for every person, and then they would try to do it every few hours, and it couldn't scale. It couldn't even last until 2008. A newsfeed was only launched in, was it 2006? It couldn't even last that much. And then, we switched over to a real-time indexing and a real-time system, very much like, the generalized version of that in some ways is Rockset, right? So you can build massive scale real-time applications like Newsfeed is one example, but it doesn't have to be Newsfeed. It could even be, a real-time dashboard that is, gives you ad hoc slicing and dicing for your business data and whatnot. So that's really where, we saw a lot of this movement towards, from batch to real-time. And that's where I spent a lot of time. My co-founder Dhruba Borthakor, started and was one of the creators of the Hadoop file system. Back in Yahoo when he was there. We also worked together on this project called RocksDB. Hence the namesake Rockset.
Yes. Okay. Yeah.
So RocksDB is open source, and that is our storage engine. We extended that to work well.
I actually used to work for a company here that used Rocks as its core.
So RocksDB it came out of my, Dhruba, I was the manager and overhead, I guess, and Dhruba was the key person that really created and shepherded the project forward. And every modern, and we open sourced in 2013, I think. And since, any new distributed data management system that has come out has been built on top of RocksDB. So RocksDB, it got extended and works very well in the cloud. It's called RocksDB Cloud, and that is also open source. So we have a lot of roots in open source. The rest of the SQL engine and everything else that makes Rockset, because Rockset is not just RocksDB in the cloud, it's a lot more than that. It's just like the Lucene and the Elastic Search comparison that you gave. It's very similar. Right, the relationship that Elasticsearch has with Lucene is very similar to the relationship Rockset has with RocksDB. So RocksDB and RocksDB Cloud is still open source.
From memory, Facebook had a reasonably well-known SQL processing library that I cannot for the life of me remember what it's called.
Presto?
Presto, yeah. Is that what you're using, or?
Oh, no. Presto is also built, there's it's called Trino, I think the open source project now. They changed the name because, for whatever reason. But no, I think Presto, when Facebook built Presto, it was really, again, for batch systems. It was for big data and batch analytics. Nobody in their right mind would use Presto to power an application. Because it's not built for application processing. It's built for batch analytics. It's a wonderful SQL engine. Huge fans of that work. If you have, like, for example, a huge data lake in Amazon S3, and you are looking for a massively distributed, massively scalable SQL engine for batch computation, where you want to generate reports on a daily, weekly basis for your analysts, my God, Presto is amazing. But I wouldn't build a real-time application on top of Presto.
Okay.
Yeah.
And so when did you start? When did Rockset begin?
Rockset, I left in 2015. So I would say Rockset was like probably officially incorporated by like the tail end of 2016 or something like that. And for 2 years, we were just deep in R&D. Like the team was like less than 10. Building a new database, especially a real-time database, is no easy feat. We came out of stealth sometime in late 2018, and then since then, we've been in the market.
Okay.
Yeah.
And then, you've mentioned high-speed, real-time indexing database, SQL querying, which has often been a kind of I can't think of the right word, but a golden thing that many modern databases have attempted to replicate because it's a language that many DBAs recognize. What are some of the other features you have apart from those two fairly big, fairly useful features? But what are some of the other features you have?
So this is great, right? These are the kind of like the bread and butter, what we're talking about, the core real-time indexing engine, where whether the data is structured or semi-structured, coming from stream-based systems or batch-based systems, doesn't matter. Rockset will automatically turn them. Okay. But on both ends, to make it easy for people to bring their data set wherever it's being stored, Rockset comes with a lot of built-in connectors. Mm-hmm. So if you're a Mongo Atlas customer, Amazon DynamoDB customer, have a lot of data in S3, you literally just have to create an account with Rockset and point us at your data set. Mm-hmm. And instantly we will go make a full copy and we'll automatically transition. Our connectors will automatically transition into the change data capture system. And so you continue to use your Mongo Atlas collections, DynamoDB tables, and whenever your application makes a change to it, within 1 to 2 seconds, it'll be reflected in Rockset's indexes automatically, in Rockset's collections automatically. So that is the built-in connectors shorten the time to build a new solution so much that one of our customers said, Rockset took my 6-month roadmap and shrunk it to a single afternoon, right? Because they had to, build all of those connectors and everything else, even if there was a quote-unquote database on the other end. And there's also a lot of innovation on the other side where applications are trying to connect to Rockset and query Rockset. And we have this functionality called query lambdas. So what's a query lambda? Take a SQL query, put some parameters on the query, just like you do in a normal SQL query. And in a click of a button in Rockset, you can turn that into a fully versioned, dedicated REST endpoint. And so you can basically go from SQL to a data API, a REST API, that's fully versioned, so you can integrate with your CI/CD pipelines. You can do tests on that and have test versions and production versions, and you can have tags and what have you. Mm-hmm. And that, I think, is a small thing, but I think it has had profound impact in large teams very quickly being able to build solutions on Rockset. Simple reason is when data teams kind of clean up data and put it in tables and then give it to their stakeholders, internal dev teams, now the expertise, there's expertise mismatch, right? Like the people who know how to query the data and know how the data is organized and indexed and what have you is not the same person also constructing the SQL query. Yeah. And in any table, you can construct a SQL query that comes back in 10 milliseconds versus 10 days. And so when you're exporting as APIs with query lambdas, it really accelerates development, accelerates innovation, and reduces time to market for building your solution. So both data connectors on bringing data in and query lambdas for building applications on top of Rockset has been just a tremendous value proposition for our customers.
And something I'm just trying to understand. So you mentioned these various data sources. Do you actually merge the indexes from multiple data sources, or is every kind of index connected to its own source?
Great question. So most sources become its own, like typically how people want is there's a table that is sourced from Kafka, like a Kafka topic becomes a table in Rockset. Mm-hmm. There's another table that is like basically DynamoDB. In the source is DynamoDB, but there's another table that sourced from Dynamo. There's another table that's sourced from MongoDB and what have you. Mm-hmm. You can join them at query time. This is the power of join. So you don't need to merge them at all, unless you really need that for deduping or something like that. That is also supported, but it's quite uncommon for people to wanting to duplicate or deduplicate and merge from multiple sources.
Fair enough.
These all just show up as tables in a single database, and you can join them with standard SQL, left join, right joins, outer join, inner join, like what have you. Yeah. Window functions, aggregations, sort by, everything is supported.
So you don't index across the databases, but you allow people to query across the databases.
Correct.
Should they so wish, and it be relevant,
yes.
Obviously.
Yes.
And actually, the same question would go for this feature you have called Smart Schemas. Is that a schema per source, I guess?
Correct. Per table.
Or per table.
So why is it smart? Yeah. Why is it smart? Again, it goes back to real-time analytics. So in real-time analytics, right, gone are the days where you can pause the world and say, alter table, add a new column, and it's going to be of this type. Mm-hmm. No, nothing is going to wait for you. There are millions of records coming every second. You have to pick it up on the fly. And so what Smart Schemas basically is, we automatically turn NoSQL data into SQL tables, right? And so we have to be very smart about that. Mm-hmm. And so when JSON data, NoSQL data is coming in, new fields can appear out of thin air. Fields can change types. And we have a very sophisticated system to automatically infer that. And it's still strongly typed. There is no type coercion that happens in Rockset. Mm-hmm. We will still preserve the type, even if a column is changing types, on the fly, or new columns are appearing on the fly. And you can still do a described table like you would do it on any other SQL database, and you still get a very detailed schema back on this is exactly what are all the fields we have seen. These are all the types that we have seen for each of those fields, and so on. And so that's why it's like still the schema exists. The SQL is still strongly typed in Rockset, but the schema is built on the fly, and you don't have to ever manage it.
Okay. And the other one I'd like to quickly dig into is you say full SQL. Now, I know many companies and projects that claim SQL on top of things where SQL doesn't really belong, and then you dig into the small print and it's never full SQL. Is it really full SQL?
Extremely good question. Clearly, you've been around. So I will tell you, any project. I'll give you a little tip. Any project that claims I have SQL-like API, they don't have SQL. Because people who have SQL, they'll just say we have SQL. They would never say SQL-like. Okay, so that's your tip. So we are not SQL-like. It's a full-fledged SQL engine with all ANSI SQL standard. The real magic happens when you throw NoSQL data at it, and then you can just now do SQL at it. Like that's where it flies in the face of what people have been told, that SQL and NoSQL are two islands with no bridges in between. Completely not true. In fact, SQL and relational data, data management, data model were two distinct, inventions that just merged together in a relational database management system. But SQL is just a declarative data retrieval language, and it has tremendous properties that also applies to NoSQL data. And so there is a very simple, elegant dot notation and simple extensions that we have that allows you to also work with nested data and what have you. That is very common in that, but it's a full feature SQL engine. In fact, our distributed SQL engine is extremely high performance. If you compare it against, let's say, things like built for batch systems, like some of the open source projects we talked about, Presto. A SQL query comes into Rockset. It gets broken down into fragments, sometimes thousands of fragments that now needs to get scheduled on a massively distributed backend infrastructure. The whole compilation, query planning, scheduling, and the initiation of the query actual execution usually takes, in the Hadoop-based systems, it would take many seconds, maybe minutes. In more modern, warehouses, it'll probably take 500 milliseconds to maybe 1 to 2 seconds. In Rockset, that whole process takes 1.2 milliseconds, right? And this tells you a little bit about why we are built for applications. Every millisecond matters. So we take a SQL engine, we fully supported SQL, window functions, group by, order by, joins, what have you, and we compile that, and we have a massively distributed execution engine that can supercharge your query and start execution in 1 millisecond.
Okay. Just looking around the kind of cloud perspective, as far as I can see, unless I'm just not understanding their product names, I can see AWS, I can see Google, but I don't see Azure. Is there any reason for that, or am I just not understanding product names?
Work in progress. No, I think data sources. So data sources can be anywhere. We have a RIDE API.
Yeah, okay,
So even if you're in Azure, you can use our APIs
This
to
is their
directly
specific
stream.
storage stuff. Okay, yeah.
Correct. You're looking at the built-in connectors, and so we are just building built-in connectors based on the kind of customer base we happen to have right now. But building a new connector is very easy with our APIs.
But when you talk about S3 or GCS, what are people querying there? Because I mean, S3 especially, you can store all sorts of things. What's the limitations? Question. I guess is the question.
So you can store data in S3, but you can't really query it, right? It's a storage system and not a database. So what happens usually is people, like, we have a hedge fund customer that has hundreds of data sources that they look into. They get all of that in S3, and they run very complex ETL jobs that read from S3 and dump it back into S3, right? Spark jobs and what have you. And then they get a 3 terabyte, 4 terabyte golden data set that they want to put it in the hands of every analyst, every investor in their company. And they want interactive queries on that. And so what they do is they basically put that into S3 and come to Rockset and say, hey, go index this data so that I can do full feature SQL on this.
Okay.
And so we are the indexing and serving layer of data that is just processed and kind of getting kind of like dumped into S3. And I'll just give you an example. They were using a modern cloud data warehouse. The queries were, for them, taking 2 to 5 seconds. And they had certain interactions where they had 30, 40, 50 queries. So you do the math. It was taking many minutes to load. They moved to Rockset. They index this data. The queries come back in 18 milliseconds. And so the entire application got about 100 times faster when they started indexing it in Rockset.
Okay. And I kind of usually have a question of like, what's the next? But I think I'm going to ask somewhat specifically in terms of data sources, what's next? Are there any popular data sources out there that you don't support right now that you're planning to?
Yeah, very good question. So I think the key set of data sources that are like, people want to build real-time analytics on more and more transactional databases, right? And we have Mongo Atlas, we have DynamoDB, and we just released MySQL and Postgres. But you can see, we leverage for that connector, we leverage Amazon's data migration service, and so the very, very soon, or what's coming next is like, no matter what your transactional database is, you should be able to, Oracle, SQL Server, maybe even on-prem. Your data can still live in on-prem, but your indexes will be in the cloud. Very soon, you can basically expect, no matter where your data is, and in terms of transactional database management systems, you should be able to leverage Amazon DMS. If you're in AWS, you can leverage DMS plus Rockset to build your indexes in the cloud.
Okay. And I guess the kind of final question I have is, how do you stay ahead or competitive with, the kind of obvious contenders here? We've mentioned Elasticsearch, and the company Elastic is probably the biggest elephant in the room for you. They have their own challenges, of course, but how do you kind of stay ahead of the limited but well-known competition in this space?
So I think, for the application use cases where you're trying to build applications which needs joins on business data, usually Elastic is not really even the biggest competitor, because Elastic is a lot more used for log analytics, right?
Yep.
This is data that is very valuable for like the next 1 hour, maybe 1 day, but after that it's not that valuable, right? And Elastic's future, I think, is going much and more to become a CM, a security company with incident management and a full-fledged log analytics end-to-end solution.
True. Yeah.
So if you really want business analytics, you shouldn't be using Elastic in the first place. And even if you were, I think Rockset is a much better match. And you shouldn't be using Rockset for log analytics. You should be using Elasticsearch for it, because they have a much better solution for that. But it's really, the competition comes from really complex, on-prem technologies that are very hard to manage, like Apache, Druid, and things like that. Which is, I think, as I said, they are very. They've done amazing work. I think it's like if I had my own data center and I'm a CIO and I have to, figure out how to, get some real-time analytics going in my on-prem data center, and I have lots of servers. I think Druid is a pretty good bet, right? But you shouldn't be using that in the cloud. Is the real the real way. And so in the cloud, I think, is real-time analytics possible? I think the real competition in the cloud is a lot of DIY. People have been traditionally solving this problem with duct tape infrastructure, a lot of spit and glue and duct tape, where disparate systems are all concatenated, and a Rube Goldberg machine of sorts is usually built to solve real-time analytics. And this is why I think the time to value, the time to market, in terms of your data assets turning into applications and being able to quickly build those applications and scale those applications, that's the value prop that resonates, because it's possible you can do real-time analytics in the cloud. It's just going to take you a lot of people and a lot of time.
Yeah. So we talked about new data sources, but my final question to always ask people is, apart from that, what else is next in the next 6 months or so?
Lots of stuff. We're actively growing. I think we closed our Series B, $40 million with Sequoia and Greylock. Doing a third time leading a investment with us. So every part of the company is growing. We're hiring more people in sales, marketing, product, engineering. You name it, we have it. We're looking for office managers because our office is growing. So yeah, I think we're growing a lot, and so there's a lot of very exciting development that is coming up. I think real-time analytics, we will do everything to, not only make it easy for you to bring in data from anywhere, but also we would invest heavily on the app connectors. Mm-hmm. So whether you want to build the application, using whatever language, or maybe the application is just a dashboard and more connectors with all the kind of the real-time BI layers that people want to visualize their data in. And so there's also going to be a lot of focus on building out the ecosystem so that the Rockset becomes the fastest place where you go from data to apps and real-time apps.
It seems like a good aim to have. So if anyone is interested, that's rockset.com. Not open source, so you can't roll it your own. And you've mentioned several times about the kind of cloud native aspect. But there is a free tier if people want to kick the tires and see what it's all about. And as far as I can tell, you get a reasonable amount for free, and then the charge is per hour. So you can always experiment for a bit without it costing too much. So,
correct. Yeah. There's a fee for every tier for hobby projects. Up until like few gigabytes of data, you don't have to pay anything. Yep. And so only for larger scale, even the pricing comes in. There's $300 free trial credits. Okay. That will take you far for you to really build, and try something out. So yeah, go ahead and kick the tires. Rockset.com also has a blog which we write a lot of content. So go check us out. Go to rockset.com and you can see the blog, or just /blog. If any of the technical details that we talked about you're interested in, there are white papers, blogs, videos of the actual engineers who actually built it, making those videos. So you would have your listeners and your viewers will have a lot of fun if they're interested. They can go check that out.
In watching more, yes. Okay, Venkat, thank you very much for your time, and good luck with the future.
Awesome. Thank you. Bye.